Alright guys, guess what? You're gonna love to hear this, Popo. I'm about to work on my printer. Right now. You heard me right. I'm about to work on it right now. And hopefully have a nice little session here, maybe a few hours. Okay, so the next task. Next, onto the motor output shaft, attach 2 circular plates that will guide the nitrile rubber belt that it will use to turn the pickup roller shaft. Okay, so we're creating little guide plates. No problem. No problem at all, boys. 2 circular plates. I think I want to make them out of water bottle. What do you guys think? That's why I've been hoarding bottles. Just this sort of thing. Hi, Adrian. I'm working on the printer. Aren't you proud of me? Use the water bottle lids. Oh, I feel like that's a little thick. I want a flat surface. Everything on this surface seems curved. That's not good. You know, maybe you're right. Maybe I should use water bottle lid. So you understand what I'm doing then? I mean, it sounds like you do. Here's my motor. And I need to create kind of like a thimble has. Not a thimble. A bobbin has for a sewing machine. It'd be funny if I could actually use... No, I can't. But this same type of concept, we just need a little guide to put our belt in. This is how our robot is going to reel in the string of its artificial muscles on a motor, turning it, and then the string will get wound up. And then we'll have a second section that's reverse threaded, which will cause the opposing muscle to pull. So when it turns this way, the opposing muscle releases and the main muscle pulls at the same time. So a single motor can cause forward and backward actuation of muscle groups for the fingers and every other muscle of the body of the robot. And it's just going to be using little pulleys with string. But in the case of this project, we're going to be using a belt for continuous rotation. And, well, wait, we don't need to use a belt. Yeah, we do. Yeah, we do, and here's why. I forgot about this. This was something I thought about early on in the project. Yes, we could have a string turn it, and that would turn the pickup roller. But when is it ever going to rewind? Like it can't ever turn the pickup roller back. So it's not like it's going forward and back. It's just going forward forever. So that's why we're using a belt system. And we're going to be making our own belt out of nitrile rubber gloves. So basically mechanic gloves. We'll craft our own belt. I could use a rubber band, but I feel like rubber bands just wouldn't last. They eventually dry out, crack, and get brittle just from exposure to air oxidation. So that's not acceptable. We want something that will last, and I feel like mechanic gloves last forever. I have them stored in boxes around my room, and they just, whenever you wear them, they're just perfect. So we're just going to build up several layers thick of mechanic gloves, and that will be our belt. But yeah, we need belt guides, just like that bobbin for a sewing machine has little plastic guides to guide the string. We need a belt guide so that it doesn't slide off of our little shaft. Well, I'll need my X-Acto knife. You know what? Packaging would be perfect. Packaging has that, like when you buy a package, it's like clear and a little objects inside it when you buy things. That type of plastic would be perfect as a guide, and it's flat. Even better than this. I mean, I guess I could use water bottle caps though, but I'm just saying. Yeah, water bottle cap's actually quite perfect. Good job, Popo. And everybody has water bottle caps. Everybody on Earth has a water bottle cap. Come on. It's already round, so you don't even have to make measurements. How do we want to cut it? What's the best way? You know what? I want to use my jeweler's saw. I bought a jeweler's saw, and I've never used it, and I'm so excited to use it, and I'm gonna use it, man. Now is the time. This is the perfect application. It's got to be. It's a precision cut. This is so perfect. This is. I knew I would need this saw sooner or later. I didn't know how long it'd take me. I'm surprised I'm already finding a use for it so soon. But this thing is able to make extremely fine cuts, like for making rings and stuff. That was very smart, Popo. That you just came out of nowhere, looking around my room, saw water bottles, and said use the lids of that. That's the kind of thinking, you know. You have the mind of MacGyver. That's why I can't really put a price on the value of being a Twitch streamer. Like, just that type of thing can save me so much time. Just having other minds, you know, really great problem-solving minds to help me out. I can be smart and creative and resourceful myself, but sometimes somebody else might see an even easier solution than I can arrive at. I'll find a solution, but having other people's input is valuable, and I do listen to suggestions. Alright, I'll help the same find this me. I got the 144 piece jeweler saw blades kit off eBay. Trying to get out late, but there we go. Okay. Alright, we need to get those tires starting here. Ah! Get back! Okay. We got jeweler saw now with the lead. Took me a while, but we got it. Oh, I don't have extension enough, this. Alright, Haha! It's going through it. Not bad. Cool. I guess I'll draw a guide for myself. Maybe I'll take it off here for that. I don't know if I can get it off. There. Man, it's making quick work of this. A little safer than trying to do it with the X-Acto knife. I don't know, I just wanted to try this new tool. It'll be more accurate and just a cleaner job, I think, overall. So I just want to establish what diameter I actually want. I'm just doing little dots wherever I want the diameter to be. Doesn't have to be that big, right? Because it's just keeping the belt in place. After the first pass of dots, the second pass, I'm going to use just to correct the first pass so that the averages of the dots will be the line I follow. Kind of like how sketching works, like you draw many lines in order to create a rough overall line that you wanted it to look like to begin with. Or dot sketching. I could always sand it with a file after I've cut it to make it more precise. There we go. The inside of that looks like a circle. Pretty darn close. With no measurement tool, just by eye. Because it doesn't need to be perfect. But I still like to have good workmanship in general. Man, this is such a cool tool. I feel like every DIYer should eventually buy a jeweler saw. It's such a precision cutting tool for plastic or anything. It's not for jewelry making. And see, that's what I was talking about when I said that I think it's important for a DIYer to learn every field. Because I'm finding that jewelers' tools are really the best precision tools that apply to every field. If you want to be a good maker, you need jewelers' tools. Jewelers pave the way in terms of magnification, precision of cutting metal. That can apply to plastic cutting, part fabrication. Just, there's a lot to learn from jewelers. If you want to be a roboticist, you've got to learn jeweler skills and get their tools, especially for small scale robotics. This thing looks so stupid and small though. But it's what we wanted. Doesn't sand too well. Huh, that's weird. I guess it's too soft of a plastic to sand well. Well, if I go in the same direction, that's helping, I guess. Maybe. Maybe not. Well, you just have to scratch off the burrs. It just creates like plastic hair when you do this. Yeah, water bottle cap was pretty darn excellent as a material choice for this. Really, gotta hand it to you, Popo. I'll probably use this for all of my future custom servo horn making, we'll call it. Servo horn pulley system guide braille bobbin making. I don't know what the heck. Alright, this is not a circle. What the heck, man? It's gonna drive me crazy. I need it to look like a circle for my own sanity. I gotta try not to be too anal because it doesn't matter, I don't think. But at the same time, I mean, if my workmanship sucks, nobody's gonna want to see me make anything ever. I need to keep a certain minimum to have the respect of other makers who watch me do stuff. Certain minimum quality level that I'll accept. Because I do consider myself a master fabricator. You can shorten that to mastercator. Chronic mastercator. To make the hole down the middle, I'm thinking... I think I'll go with X-Acto knife. The good old spinning X-Acto knife kit trick. Okay, holding this is making my fingers stiff. It's not comfortable holding something so small, so tight. There we go. Ooh, watchmaker tools. I'll have to look into that sometime. If YouTube ever gets around to recommending. I usually don't buy tool sets. It's a lot cheaper to buy just individual tools than sets. Sets are bundled and marked up. Like I just bought a dent puller for paintless dent repair. If I would have bought this set, it would have been like $115, but just buying the dent puller by itself is $15. And then I also bought a dent lifter tool. I can't wait to start doing paintless dent repair. A little bigger. I want it to be like a press fit. Uh-oh. Let's clean up the edges a little bit here. They don't sand well. They just get a chewed up plastic look. I need to slice away the chewed up plastic. I'm just doing this before I give you my close-up, dang it. I refuse to give you guys a close-up of some crap. He needs to look decent, man. I'm trying to make a name for myself here as a master craftsman here. Why should I have to deliver crap work? Alright, ready for my close-up. Now the money shot. Okay. Not bad, right? Pretty good. Not bad at all. It's okay to cut toward your fingers if you're making very tiny little strokes. And it also depends what muscle groups you use. Certain muscle groups, if you cut too much, something can really go flying. But if you're just using small muscle groups, the total follow through of a missed stroke won't go far enough or strong enough to injure you. Teaching kids how to cut away from themselves is a good practice, but once you become a master craftsman of 20 plus years experience with your hands and cutting things, those rules can be broken. Alright, I need another bottle cap! that one's ruined. Here's the bottle cap I made it from. can see where I entered and made my cut. It's pretty accurate. Pretty decent circle. Bottle hoarding always pays off. This is not good. It's reinforcing my hoarding. That moment when the hoarder gets rewarded for their hoarding, then they become 10 times worse. It's like, oh, we need to save every bottle now. Because one time I used one for a project. Never throw away a bottle cap again the rest of my life. Oh, now it's got to match the size of that one. This one's harder. I need to measure this diameter. Much better marker for this would be my new Stradler 0.2 millimeter marker pen thing, which is used for drawing electronic circuits directly onto copper clad board and then using a copper etching solution to make print your own hand circuit boards. And that's going to be a very, very accurate marker for me. The fine pointed Sharpie is okay, but for something like this, even something sharper would be better. Can you put the old one inside the new one to make a template? Oh! Yeah, I could have. That's a good idea. I guess I didn't want to take the old one off. It's so perfectly positioned, but, that would have been a great way to do it, yeah. Just trace it. Too bad I didn't read that earlier. That's what I get for not reading my chat. You know, I had, I believe this is called a jigsaw. I had a jigsaw like this for years, but it had a really rough wood cutting blade on it, and I never needed it for wood cutting. Who needs a jigsaw for wood cutting? Like, seriously, if you're going to cut wood, you use a sawzall or a circular saw. It was the most useless tool. I never used it. But now I finally have a jigsaw that's worth using, and that's one that actually can cut metal or plastic with very fine precision. That is something I can see myself using a lot. It's all about having the right type of jigsaw. Who the heck needs some rough wood cutting blade? Like, nobody's gonna cut like a 2x4 with a jigsaw, so why would you need a rough blade for one? Fine blades are perfect for a jigsaw, for precision work. Stuff that you wouldn't use a sawzall for. It's the only time I see myself using a tool like this. And I have an electric jigsaw too. I would rather use that. Like, why would I use a handheld jigsaw with some rough, crude blade? There's just never going to be an application. Hi, Cookie. That would be a coping saw? Oh. Hi, TXT. Normally I was making these out of poster board, but I like this because it's waterproof. Poster board you'd have to coat in epoxy after, which is fine, but using water bottle caps to make little guide rails for servos. Or I can't even call it a servo. I mean, I guess I can. For servos. For custom servo pulleys, we'll call it. Is pretty darn nice, I think. It's like a... it's just a good material choice. This one's bigger, but whatever. We screwed that up, but I don't think it matters at all, and I'm not going to make it smaller. As long as the circle is nice and round, we'll just pretend like the outer one needed to be bigger because reasons. They don't have to be the same size. The only point of these are just to keep the belt from slipping off the DC motor output shaft. That's it. Actually, these weren't round diamond coated blades. They're just really fine steel blades. What am I making? I'm making a plastic guide for a belt pulley for a custom DC motor output shaft for a laser printer pickup roller power assist system. Why'd that have to be so many words? know what it means. Neither do I. What did I just say? Hey, I know what would be good for this. A toenail clipper. Note to self, the material that makes a water bottle cap is very similar in consistency and translucence of a fingernail, so it'd make kind of a good artificial fingernail material, I think, for my robotic fingernails. Although I might just buy the fake fingernails from the dollar store for women's fingernails to make my robot fingernails. Or I could just pull off all of my fingernails and use it for the robot. They'll grow back. I'm sure it won't hurt that bad. Just take a pliers and pull them off. It'd be good training as well in case if anybody wanted to torture me for information in the future. I'll just laugh and say, hey, I rip off my toenails as a hobby. You don't threaten me. My toenails and fingernails, I rip those off all the time. You don't scare me. You're going to have to at least pluck my eyeballs off to actually make me shake in my boots at all. Congratulations, Adrian. Or am I supposed to feel bad for you? My mom was not happy when she turned 40, if I recall. You gotta look at the bright side. You made it to 40. And you're still a virgin. That's a tremendous achievement. Alright. Time to glue. Uh-oh. Always put paper towel down on your shirt first. I don't know how many shirts I've ruined with a drop of super glue on the stomach. I just hate that. In this application, I want it to go on thinner, so I'm just gonna use the spray. What the heck? Weird. Okay. The spray's not spraying well. I don't know what's going on. Alright, it's so darn ugly looking, but I think it's fine though. Alright, next one. There. I guess I shouldn't pick at it too much because it needs 24 hours to get to full strength. And besides, it's friggin' great. I mean, it's a little rough on the edges because when you sand the plastic, it just creates little fuzzy spots. It doesn't shear off clean. I could pick at this thing forever, but at the end of the day, I mean, that's a really good job, honestly. Really good job. If I had an employee submit this to me, I'd be like, I mean, it looks kind of crude, but this will work. I would approve. At the end of the day, it comes down to functionality. It's not bad. What belt am I going to use? A homemade belt using nitrile rubber gloves, mechanic gloves. I'm just going to layer it up in layers using double stick tape, stretchy double stick tape. So I'll just keep building up glove, tape, glove, tape, glove, tape with double stick tape, building up a thick band. And I'm going to coat that band with anti-slip carpet paint for like throw rugs or throw carpets so people don't slide when they step on them. And that will cause it to be grippy rubber. And I'm going to coat that onto the pickup roller shaft as well. And I'm going to coat that onto the inside of this thing as well. I'm going to thicken up this diameter though, so it has more grip. It's too small right now, so I'm going to wrap it to really beef it up. Yeah. I'm going to beef it up a lot more. Because if the axis of a shaft that turns gripping a rubber belt, if the shaft is too small in diameter, it's just going to spin in place, not gripping the belt. Because the total surface area of the shaft coming into contact with the belt will dictate how much friction is being developed and how much force transfers onto the belt to turn the belt. I do want the belt to have slippage because if the timings are off, I don't want the belt to just snap or stretch out too much. When the belt starts turning before the printer is really ready for it to be turning. So I want it to turn in place to some extent, but I want it to also apply a tiny amount of force onto the pickup roller shaft because it is, after all, a power assist mechanism meant to help with the turning of the pickup roller shaft, which is weakened because of a weakened magnetic clutch. Alright, so that's finished off the to-do list. Next, onto the motor output shaft, attach two circular plates that will guide the nitrile rubber belt that we will use to turn the pickup roller shaft. Done. Get wrecked. Now unplug the motor and wrap its output shaft with nitrile glove tape until it is at least 6 millimeters in diameter, which will make it have a larger surface area with which to grip a taut nitrile rubber belt, which it will be using to turn the pickup roller shaft. Okay, so that's our next job. We don't huff glue around here. We're innovators. We have to keep our minds sharp. This is a stream for scientists. It's kind of funny seeing something I wrote down, visualizing in my mind coming to life. I don't know, it's just. It seems like so often everything I come up with is just so esoteric. Let me make sure I use that word correctly. I think I used it correctly. It's weird to see things becoming reality because I talk so much about stuff that people don't think will ever be reality, and sometimes seems like it will never become a reality. And then when something does become a reality, it's like, what the heck? I'm looking at something I just came up with, and I'm actually doing it. Wake up. Esoteric. Press return. Oh, that's not the word I meant at all. No, that's not it either. I don't know the word, but it starts with an E, I thought, and it meant like something that's only in the mind, something that is just imaginary. But I guess that's not a word, I don't know. I always talk about things that are just concepts, and so that makes it weird when I actually do something that's not just a concept, it's actually a carrying out of a vision, and I'm used to everything just being visions. As people always warn me, things in your head sometimes are harder to actually bring to reality than you think in your mind or whatever. Alright, I think we'll do one more of those, and we should be thick enough. I'll trace this one maybe. I don't know. Yay, I'm glad to hear that, Adrian. I thought about supporting this shaft with I don't know what they call it, like a lazy Susan in the lathing world. It's basically like a little like what my thing's doing here. It would just kind of guide it so that this doesn't bend the output shaft. But I figured with something so small, with low forces involved, I don't have to worry about this shaft getting bent. But in my robotics applications, like the bicep muscle, yeah, this thing will get bent. So I will have to support it. And I've got a support mechanism designed out already. And I'll show you guys what that looks like. So basically that's the motor. And there are the two muscle shafts with the, well, you can see here, those are the pulley guides, which is just hollowed out electrical tubing. And then, hold on a second. Ugh. I need a pointer. I can't talk without pointing to what I'm talking about. Okay. Alright, so then this is the motor, this cylinder, and then it's strapped to a nail going across, and then this will just be like a ball of PVC sewn onto the nail, and then thread will come down there and there, strapped down onto the bone of the robot. And then these three discs are just bottle caps cut into a circle and drilled through and just slid down and glued into place onto the output shaft of the motor. And then I had a little bearing ball drawn in here. I don't know if that's necessary though. It could just be PVC touching the rotating axis directly. but maybe the bearing ball would create less friction since it'd be metal on metal, and I could put a little bit of grease on it, and it would maybe just roll in place with a little cupped PVC container. Uh, and that the top of that will be connected to this nail going across, so that way it won't slide off the shaft, because it will be then connected by a solid nail to the shaft, so it couldn't slide off. And so that will keep this thing in place, and then these strings coming down the side will keep it pulled down, so that all the forces are going to be pulling up on this shaft, so this is pulling it down, counteracting the forces of these strings coming off. And then the strings will turn and go down left or right down the robot's body for the muscles actuation. So anyways, that's how our muscles will be mounted to the robot, and we're kind of doing something similar here, or a variant of that. But we're not going to be supporting the output shaft in our application here, because force is great enough to bend the output shaft, in my opinion, will not be being placed in this application, because we're just turning a belt. We're not actually pulling string. So there's not going to be like a bunch of pulling force being exerted onto the motor. Yeah, when I have the two extra arms, so I'll have 4 arms, Dr. Octopus style. Yeah, they could definitely give me high fives. That's true. That'll be nice. But nope, I can't give preferential treatment and bump them up higher on my priority list, because then where does it stop? Every new shiny thing will just get bumped to the top, and all the old projects will just get forgotten. And if I feel that when I add a project to my to-do list it might someday get done, that's going to be very discouraging, and it will even encourage me to stop having ideas, because I know I'm not going to get any more ideas done than the ones I've already written down, and even those I won't get done. But if I write down ideas knowing someday I will for sure get around to each and every one of them, then I can be truly excited when I write an idea down, because it means that that idea will happen. And knowing things will happen makes them real. And making them real makes me genuinely excited. Unlike somebody that just has good ideas and knows they'll never act on them, and so it's not really that exciting. A good idea is just another lost dream, another failed hope. I'm not that guy. I do my dreams. I bring them to reality. I'm a dream liver. Okay, so what's next? Let me trim away some of this fuzz on here. That sanding kind of scuffed up the edges of my 1000 denier nylon fabric strapping for my motor. Man, this is fun to even look at. Look at this little guy. It's beautiful. He's just gonna be able to turn the little belt, man. It's awesome. We did it. We absolutely did it. Alright, so now unplug the motor and wrap its output shaft with nitrile glove tape until it is at least 6 millimeters in diameter, which will make it have a larger surface area with which to grip a taut nitrile rubber belt, which it will be using to turn the pickup roller shaft. I think it's plenty thick enough now. In fact, it might even be 6 millimeters. Let's see. Oh my gosh, it's actually exactly 6 millimeters. Oh man, am I good or am I good? And you guys don't think I can build a robot army? Ha! What a joke! Look who's gonna get the last laugh. It's not just ideas, guys. I got the skills. I got the follow through. I got the stubbornness. I got the determination. I got the time management skills. It's all going down. Next, paint the motor output shaft with anti-slip rug paint to make it grippy. So the point of that is if this thing spins and it's got a belt wrapped on it and it's slippery, the belt's just going to not be pulled on. Now, a lot of times to get around that, CNC machines, for example, will use a toothed pulley with teeth on it, and then the rubber belt will have teeth. And as the pulley turns, the teeth grip and it causes the belt to turn. But I want to allow slippage, so I'm using a smooth pulley and a smooth belt because this thing will sometimes turn too fast or turn too soon, and I don't want that to cause stress or damage the belts or the system over time. I want it to allow some degree of slip, but not so much that it becomes completely useless. I still want it to apply forces. So that's our next step. I'm going to put away everything though. What ends up happening is as I do one job after the next, the pile of things in my lap just gets out of control. Oh, and by the way, I received my, huh. I could actually use this for the belt material. I might do that. This is, crap, what's it called? Strong and stretch. It's that elastic cord we bought on eBay for like jewelry making and stuff. Look at this. My intention for it though was to use it for sewing like stretchy clothing, like lingerie. Not that I would ever need to sew lingerie, but you could sew lingerie with it and it would still stretch. So for different tailoring things. And also for artificial ligaments for the robot. To add more strength to like the ligaments of fingers. Well, heck, the whole body. And maybe even to add additional strength to the skin in certain areas that needs more strength. I could like sew this into the silicone just to shore it up, strengthen it, or repair it. So the applications for this are endless, really. But it looks like we could just wrap this around the shaft, and it's kind of grippy. It's some kind of rubber type material. Look at this. It's got a lot of stretchiness to it. It seems very resilient, and I bet you it lasts forever. It's like little fibers woven together of some type of really strong rubber. I could just wrap that. But you know what? I don't think I will. I think it's actually easier to use this stuff for my belt. Because it can be cut as a belt. So I'll just stick with this, but... well, I mean... I don't know. Nah, I'm going to stick with the actual original idea, but... I like that I'm starting to think of ways to use that stretchy cord. Because... whenever you get something new, it's kind of exciting to have more tools, you know, to apply to projects. And that will be a powerful tool for me. I think I'll keep... well, I'll put this back too. Alright. Is there a chance the tape will unwrap due to heat and friction? No, as a matter of fact, well, pressure and heat make this type of tape cure even more, even stronger. But as far as unwrapping, you just have to make sure the end of the tape is in the direction this thing's going to be turning, if that makes sense, so that it would just pull on more as opposed to undoing it. So I have to make sure I wrap it in the correct direction. So like the belt will be getting turned like this. We got to make sure we wrap it counterclockwise, I think. Wait. Yeah, counterclockwise. Because this is turning clockwise. Yeah, the same thing as Teflon tape. That's so funny you brought that up. Yeah, like when you put Teflon tape on a pipe nipple, you have to put it on the right way so that it tightens more when you screw it in, as opposed to unwinding as you screw it in. Next, paint the motor output shaft with anti-slip rug paint to make it grippy. Alright, let me go get that from my closet. That's one of those rare things that I don't keep on the shelves next to me because I don't see it as being something I'll use often enough to justify storing it on the shelf. I prefer to store things on the shelf that I know I'll be using all the time. I have to show my wife this motor. It's pretty cool. I like to show people my creations. Alright guys. This is it. Fiberlock non-skid rug backing. You paint it onto rugs and it makes them grippy. So I'm going to paint that onto this shaft, little dots of it, and it should make it really grippy. At least that's the theory. I think it makes perfect sense. But I'll be right back though. Oh, I need to make sure the overlapping edge of the way this motor's going to be turning won't peel back. Just like Teflon tape, you gotta thread it in the correct direction. I gotta do that for this part too. Thank you TXT for paying attention to that. This thing would have for sure peeled off. Well, maybe not for sure, but better safe than sorry. Have the ending flap end in the direction where it will be tightening on rather than coming off. Needs to go clockwise. The motor's actually going to be turning counterclockwise. Okay. The fiber lock non-skid rug backing next. Okay. Apply 2 thin coats with brush. Will appear transparent when dry and ready to recoat. Clean brush with soap and water. Alright, to apply it, I'm going to use a tiny applicator. Dries clear, it said. Man, I'm just using all my new toys. These are my new applicators I just got. I guess they're called MA100, I don't know. They're super fine applicators. Little fine brushes that I bought. They're like $1 on eBay. I think just type in like super fine applicator brush or something. There it is. It's not as fine actually as the finest artist brush tips though. But it's still pretty fine. It's funny, I saw these in a hobby shop and I was like, I gotta have that. I thought I'd be using it to retouch like chips or scratches in a car though. I didn't anticipate using it for creating stickiness on a belt system. But go figure. Alright, it'll be super grippy now. My initial intention for buying this non-skid rug backing was I wanted to put a mesh jersey material for a football player practice jersey across servo motors with anti-slip or non-skid rug backing by Fiberlock. I wanted to put that on the jersey, wrap it around the servo motor, and then sew it real tight on there, and then sew it into the bone of the robot. And that would prevent the servo motor from being able to turn, or the DC motor from being able to turn. And the idea behind that was I wanted it to be breathable still, so the motor could not overheat. So I didn't want to just wrap cloth around it, or double stick tape. I wanted bare metal to still be exposed while still gripping it tightly. And that was the ultimate solution. And I came up with that laying in bed. And that's part of why I'm the world's greatest roboticist. Because of ideas like that one. The self-proclaimed world's greatest roboticist who's never built a robot. But you'll see. They'll all see it's true. I just need time to prove it. Okay. I just cleaned that with some Water Plus dish detergent, which I keep in a Windex bottle, and that cleaned out all this non-skid rug backing from my applicator, so I don't have to throw away the applicator. It only costs like a penny, but why throw it away if we don't have to? Alright, so next paint the shaft with non-skid rug backing to make it grippy. Check. Alright. Next, set a 100 NF ceramic capacitor, aka 0.1 UF, bridging the two pins of the motor. Also set a 1N4004 diode bridging the two pins of the mini motor, with its striped side facing toward the positive side of the motor. Oh my gosh. How the heck do I know which side is positive? Oh, just whichever side we treat as positive, basically, then. Which I don't know. Huh. Alright, so a subtask on that is just to plug in the Arduino and somehow connect it to the motor and see which way makes the motor spin the right way, and then we'll know which way is the positive side. That's the only way we can do that. So let's put it on our stomach table and go from there. Okay. Alright, so I have to plug this in. Let me get out my plug. And my... This is going to be too much, though. We need a resistor. Oh my gosh. This could burn out the microcontroller if it's not high enough resistance. This one and this one then. This one does go through a resistor. What's the resistance value of that resistor though, I wonder? I need to know. Well, I equals V over R. Let's do some math. Holy cow, we need to determine the right resistor for our need. So I equals V divided by R. And I has to be 20 milliamps. Equals 5 let's say it was 5 divided by 200. 5 divided by 200. This is going to be for amps. That would be 25 milliamps. Okay, 5 divided by 300. .16, 0.016, so that'd be 16 milliamps. That's safe. So we need a 300 ohm resistor in order to run our motor off the Arduino safely. Oh. I mean, technically this could be bad for the microcontroller too. I'm supposed to put a diode and all this crap. Wait, I know. I'll use a battery. Yeah, we'll use a battery. Okay. Let me stick that here. This battery is... what's the voltage? I don't even know. Let me test it. .7 volts. Okay. That's perfectly safe for a motor. So let's just connect. Wait, let me make sure. I want to check the polarity real quick. Alright, polarity check. Alright, so the red one is positive. Got it. Okay, it actually shows it on the labels. Alright. It's moving. You guys see it moving, right? That's awesome. I just love seeing electronics come to life like that. Alright, it needs to turn the pickup roller toward the front. That's the wrong way. Let's make sure it's the wrong way. Yeah, that's the wrong way. So the top one needs to be positive. Got it. Let's make a little marking indicating such. Really wish I had a finer tipped marker than this, but we'll just make do. So the positive needs to be, top needs to be positive. Alright, so I just marked a little plus and minus here. There's the plus, there's the minus. Labeling these little connectors here, these little copper connectors in the back. So now we know which one to connect which to. No, these are actually Adam's batteries. These batteries are for Adam. But obviously Adam's going to need a lot more than that, but I just had to buy some to get me started. We're going to buy more batteries over time. And I'm sure that my patrons, aka my Twitch chat, will pay for all the batteries once they see that I'm the real deal. So once I get the robot moving using AC-DC converters, people will fund me buying all the batteries I could ever need, because they'll see that I'm legit and I'm worthy of funding. But right now, everyone's still in the phase where they think I'm just a joke. So funding is a little more hard to come by, even though I do get some. But it's mostly just troll donations. Not so much like, here's some money, go make the world a better place type of funding. Okay, so let's get back to what we initially set out to do here. Set a 100 NF capacitor, aka 0.1 UF, bridging the two pins of the motor. Also set a 1N4004 diode bridging the two pins of the mini motor, with its striped side facing toward the positive side of the motor. Now we know which side's positive, so that will help us a lot. Okay. Stripe side faces toward positive. Alright, so we want it like that. Perfect. Alright, I'm ready to solder these. We got here our little ceramic capacitor and our diode on a little SMD to dip style breakout board, which I'll just zoom in on to show you guys. There they are. Boom. So we're gonna solder those components onto this board. They're just stuck in rough right now. It's uncomfortable holding this thing. My hands are stiff today. I don't know. There. That's comfy now. Wonder if I could even snap it one click. Beautiful. Alright. Got the flux on. Now I'll take my... I need to clean my soldering iron real quick, too. It's been a while since I cleaned it. I don't like that. Gotta keep your iron clean. Saves you hassle later. Okay. Alright. What the heck? I'm trying to bridge these two pads, but I can't even get the pads to take any solder. That's weird. Alright, I bridged them. Good. Let's try to bridge the next group. I don't know why I'm not getting solder on the tip, though. Let me get flux on the pads first. Okay. Well, that went well. I think we're good. I think I did it. Let me show you guys what I did. I should probably clean it up a little first, though, before the big reveal. It's supposed to be no clean flux, but looks like it needs a cleaning to me. It's all brown everywhere. This is isopropyl alcohol. Alright, I'm going to use a X-Acto knife to point with, so you guys can see me point out what I did. Alright, so there it is. You can see I created a little solder bridge right here. And right here. Between the two pads. It's just a bead of solder. What do you guys think? Did I do a good job? Oh, there's some, where is it? It's just some Q-tip stuff. So anyways, the ultimate test, though, is going to be multimeter continuity test. Just to verify that these bridges are, like, sending current from one component to the next, which is what I expect them to be doing. But you gotta test. You can't assume. Can't just assume everything's right. You know what? Before I even do that, I need to put away the alcohol. That's gonna fall off, spill everywhere. It's expensive. Not really, but kind of. Alright. I just had to clean that gunk off. It's disgusting. So let's go ahead and run our test, continuity test. From one component lead to the other. Rock solid. Okay, everything's fine. We're killing it, boys. We're killing it. I'm gonna do the next step too. Like, I want to stop now, but I have to go a little bit further today. Um. Alright. So the diode bridging the two pins of the mini motor has its striped side facing toward the positive side of the motor. Striped side facing positive. Here we go. I wanted to try to use a pre-cut length of wire. Okay. Perfect. Okay. Um. Holy crap. Okay. Ha ha ha. That's not gonna work. Ah! Come on, stop moving, you piece of crap. Oh my gosh. Alright, guys. Uh... Here's a soldering of the motor. You can see the little pins coming up off the original shafts. And the big blobs coming off the little spade connectors. I used a lot of solder. Nothing failed. I succeeded. I always succeed. This is all for the printer. Alright. So now... we can connect that to our board. Protection circuit board. I would like to cut this board in half, actually. So let's do that first. We'll just keep the part with the components we want to keep. Okay. I don't know where the other half of the board went, but now we just got the relevant part of the board. There we go. And those are the 0.1 UF ceramic capacitor and the 1N4004 diode. Is it 1N4004? Yeah, 1N4004 diode. And the two bridged pads so that the two components are connected. And then the legs of the capacitor now, we're going to connect up to these legs we just sent up from the motor. This way the motor has circuit protection. So we'll just solder these next. Why do I need the other half of that board? That thing's gone. I disagree. I don't think I need it. The positive side of the diode, again, goes toward the stripe side of the diode goes toward the positive side of the motor. Okay. Beautiful. So now the motor has all of its protection circuitry. Ha! We did something else off the to-do list! Woohoo! Set 100 NF ceramic capacitor, aka 0.1 UF, bridging the two pins of the motor. This is what we ultimately did. So I get to cross that off. Set a 1N4004 diode bridging the two pins of the mini motor with its striped side facing toward the positive side of the motor. We were able to determine the positive side of the motor and set up the positive or the striped side of the diode facing the positive side of the motor. We marked the positive side of the motor with a little plus sign here with a marker. So that's connected to the positive side of this diode. So we did that too. So that's done. The next step would be to solder jumper wire to the mini motor so that we can connect it to our breadboard. And that part I could do it. I could, but should I? Alright, fine, I will. This is the last thing, though. I'm freaking wiped out here, man. I want to call it a day. I'm tired. I'm reaching down deep in myself right now. Ooh, we got just the wire. These guys, because they don't have any, whatever stuff. Alright, we'll take a black and a red. Wait a minute. Yeah, we'll just stick it right in this part right here. That's sweet. I am dripping that flux everywhere, out of control here. Right where we made our bridge. Okay. Uh-oh. Can you guys even see what I'm doing? Oh my gosh. Sorry. So here's our black line, and it's now running out of that little bridge. We just connected it to the bridge. So that's how we'll tie into the motor now. And we'll do the same for the red line. What the crap? My soldering iron tip is filthy. It's snagging on everything. I don't get it. Alright. Alright, that's done. I just want to clean up a little bit. I'll use a wet wipe. No wonder the soldering iron was dirty. It clipped the edge of this fabric. The fabric's melted, so the iron must have touched the fabric, and that's why it got compromised. No wonder it was like, oh, weird. Smoking funny and stuff. Alright, so we got nice long wires coming off it and all the protection circuitry is in. Whew. So that's the final motor pretty much. I'll zoom in for you. So you see the custom output shaft for the pulley in the front. And you see the protection circuitry with your diode and capacitor, which prevents sparks or electric being produced from the motor from actually damaging the microcontroller in the event that the motor turns when the microcontroller is not expecting or whatever. And then you can see how we come up from the bottom pins where the motor connects with a couple little wires, and then those wires make the turn, and they connect to the two legs of the capacitor. The capacitor and the diode are mounted on a little board, and we bridged the two pads of the board, and they're still bridged, and we used that bridge as a place to mount our wire, which turned out quite nice. Ways to improve this in the future would be probably to hot glue the wire so that it can't wiggle back and forth and eventually snap off. In fact, that should probably be done immediately, honestly. That's a huge concern. That can mess up everything. Let me just do that. Hot glue will secure everything. That does not want to dry at all. I have to wait for a while. Yeah, you do not want these jumper wires moving at all near that compromised brittle joint that soldering creates. It's very, very brittle. Okay, so I'm just securing different key spots of this red wire right now. with hot glue, so it won't move at all. I secured it on the side and where the joint is. The streams aren't even short. I did 10.5 hours today. So now the point where it bends is far away from that joint. Now they're only bending way down here. You can see what I mean. If I zoom in a little bit. These are bending way down here, but they're actually soldered in way up here onto the board itself. Bending only down here. So you can see that's going to put no stress on that joint. So that joint is never going to be compromised or even threatened by rerouting of these wires. And that's critical to learn to always do as a roboticist or any type of electronics projects guy. You want to really protect your solder joints, especially if you're not going to be using spade connectors or any type of special connectors and you're just going to be soldering. I'm just pulling away those little threads or hairs that hot glue tends to leave behind. Okay, that's ready to be mounted pretty much, if you ask me. Yep, we're getting it done, boys. So solder jumper wire to the mini motor so that we can connect it to our breadboard. That's done. Get to cross that off. Epic day. Epic progress right across the board. I swear I can barely speak. My words are slurring. I am so tired. And I haven't eaten or anything yet.